It was this problem from homework 4.1. I was supposed to return it today, but I wanted to talk about it a little bit. So there's this rational function in z, and it's decomposed like this. For us, this time it's a plus, so 2z survived in there. It's decomposed, and I have the graph and sketched in here, so I can quickly copy that. This is right. This one, and it's the one that we had it there. So here's the curve. All right. So how did you do this problem? Anybody have a good idea? The singularity is there, the function is there, and we're about to integrate with this loop, and this time is a correct orientation. So we see cosine 5t and sine 5t, that kind of determines orientation. If you chase around, I think it has a counterclockwise rotation. These are the two singularities, 1 and -1, and 1 is here, and -1 is there. Okay? So at this stage, I was thinking that if you look at 1 and ignore the -1, so we're just integrating over that part, and think about how many times is going around that 1. Did anybody? I think it seems like it's rotating 5 times, but a couple of times it's going to miss. Anybody count that and remember how many times it's actually going around? Was that 3 times or 2 times? So let's chase it around. I didn't have a secret to this one, so you have to carefully look at this one here. So where does it start when t equals 0? T equals 0, that whole thing is going to be 0, right? And that t equals 0, the 0 is 1, and that's a 0. So is that 2? It starts at 2, right? That's where it starts. That's the beginning point, t equals 0. It's going around. So think about it around as 1. So on this part is the first coming around here. That's the first rotation to go around, right? And the second one, and this one actually loop around like this. If you look at the second rotation and going around, it doesn't go to the right side of the 1. So it doesn't really count as one rotation, right? So you go in here, and now finally end up at here. That's our second rotation around 1, right? And if you go around here this time, again, this one ends up in the right side. It's a third rotation. Maybe you don't have to do this. Just look at the right-hand side of 1 and see how many intersections are there. This is the beginning point, and this will indicate how many times it's crossing in here. This was the third crossing point, and as you go around, it's coming back, right? So there, around 1, this looks complicated, but it's really just 3 rotation, right? The one that failed to do that, I think, is around here. That one away from singularity, this loop in here is actually 0, right? So it's a 3 rotation. So what do you think the answer to this one's going to be? That's exactly that. So here, entire c over z minus 1 dz. What is the answer? Usually it's a 2 pi I, right? If it is just a 1 rotation around it, but there's a 3 rotation, right? Well, it goes around like that. You carefully go around -1 and count them again, and multiply right number, and that's how you do it. So I'm not going to repeat this again for the -1, but that's the idea. Okay? Any question about this problem? All right. I don't know how. I'm sure you can apply the Cauchy's formula directly to that as well, I guess. But this makes more sense to this stage right now.